Okay, so before we jump in, just a couple of answers to some questions that folks wrote up about the syllabus. This was one of the assignments that most everybody has turned in already, but I asked if you had any questions for me after reading the syllabus. So here are two questions. If there is a severe weather hazard in my town, but not so much here in Greenfield, what is the documentation you are looking for? Great question. If you feel like you cannot get here safely, then by all means stay home. I don't need any documentation. Like I'll hear the weather report and know that it's pretty bad in the hill towns or wherever, even if we're open here. I will take you on your word if you say, hey, I just couldn't get here. I do record the videos on YouTube. It's not the same as being here in class because I'm only recording the demo part, but it's something that you can check out if you're absent. Is this course going to be as fast-paced as Math 095, which was the introductory algebra class many of you took before this one? Honestly, I think this is a faster paced course than that one. So that's probably not the answer this person was looking for, but I'm just trying to be honest here. I think that this is a more intense course than that one. But the fact is, by being eligible to take this class right now, the GCC Math Department has said to all of you, we think you have a decent chance to be successful in this class. It's going to take a lot of work, but you are here because we think you can do this. Thank you for the questions. Okay, quick look at our calendar. Today is lesson number 4. We are going to cover something called dimensional analysis and ratio and proportion problems. A couple of notes. First of all, this is supplemental and is not technically in the textbook. Now, you might not think we have a textbook, but we do. I'll actually hold it up here. The textbook that the My Math Lab course that we're using is this one, and this is what you have a complete copy of, but it's digital. But there's still a textbook underneath. And the fact is this material is not explicitly in the textbook. So what that means is that when you do the homework tonight for this stuff, you aren't going to have all of those wonderful resources on the right-hand side, like help me solve this and pick a similar problem, because all of the problems, I think almost all, if not all of the problems in tonight's homework are ones that I typed in literally word for word, and I typed the answer in, and so I didn't type in, and I don't have a way to make all of those wonderful resources that My Math Lab has embedded in it, right? This is one of the few times where you won't have all of those nice links on the right-hand side. It also means that when you, like if you get a problem wrong 2 or 3 times and it says your final check and you still get it wrong, you can click, you know, like a similar problem, but it's not going to change the numbers. It's just going to keep giving you that same problem, and you'll get 100 if you eventually get it right. Doesn't matter how many times you get it wrong, right? Just want to get to the place where we can get it right, but the problems aren't going to change at all because I typed them in. Okay, other announcement. We have technically 3 homework assignments that were due today. I will walk around and give folks credit for that have done it. Normally there's only just going to be the 1 homework assignment due every day, but I wanted to give people some time to get logged into My Math Lab here at the start of the semester. So from this point forward, no more than 1 homework assignment will be due on any given day. So today's homework assignment is assigned right now, and it's due at the start of Friday's class, or next class. Okay? All right. So all that said, let's jump in here at the top of page 27. This demo is particularly long. We're going to kind of whip through it to make sure you have enough time to just practice on your own in your groups. So hold on to your hats. Daily summary. In this lesson, we learn how to use dimensional analysis to do unit conversions and to help us set up proportions to solve application problems. Just a reminder here in number 0, if you answer a homework question on My Math Lab and you think you got it right, but My Math Lab says it's wrong, send me a quick email. Hey, Ian, can you look at homework number 4, problem 7? That's all I need, and I can look and see what you've done. You can save yourself a lot of frustration because maybe it's just a very small syntax thing, or maybe it's a more fundamental error and you're really missing the boat. Either way, I can identify that and help you, okay? I did have somebody email me yesterday, said, hey, this is what you asked for, and take a look at this problem. And so I went in and looked. And this person, it didn't appear that this person had answered the problem. I can see the answer that you type in, even if it's wrong. But as soon as you click on a similar problem, it wipes out your answer and gives you a brand new problem. And that's what this person did. So if you have the wrong answer and you think it's right and you're going to let me know, do not click similar problem, because that starts the whole problem again, right? Just leave your wrong answer in there, save the wrong answer, and then send me the email. Okay. Number one, gas costs $3.57 per gallon. So I wrote this problem just a couple of years ago, and this was accurate. Now, I had no earthly idea that we were going to be paying $1.75 a gallon. Like, it's crazy to me that we're less than half of what we were not that long ago. But anyway, that number was realistic at one point recently. You fill your car with 12 gallons of gas and then buy some items for $15.35 at the counter. That's additional items to the gas. How much money do you give to the clerk? Before we type anything into the calculator, we're going to write down what we're going to type in. So everybody's writing down a calculation. You've got three numbers in this problem. You're going to do some things to those three numbers, and then we're going to type it in the calculator. Yes. Okay, so I'm hoping folks wrote something like this. You take the $3.57 per gallon, multiply by the 12 gallons. That tells you the cost of the gas. You add the $15.35, type it into a calculator. And it turns out it's $58.19. No problems, right? Okay. The numbers that we wrote above don't have any units on them. Remember, units are things like feet and inches and seconds and dollars. Anytime we create an equation that comes from a word problem, the units on the left side of the equation have to equal the units on the right side of the equation, and that fact is going to help us out quite a bit. What are the units on the right-hand side of the equation above, that 58.19? Definitely dollars, that there, which means the units on the left-hand side must also be dollars, right? It's not going to say $58.19 equals 3 oranges, right? It can't, the units have to match up. So let's examine number 3. What happens to the units as we perform the calculations? We'll fill in the blanks below with the appropriate units, and we're going to be writing words in each of these blanks. Let's give it a shot. We'll start with the easiest one, 1535. What are the units there? That is definitely dollars. The 58.19, we've already decided that's dollars. So far, so good. Next up is the 12. 12 what? 12 gallons. Okay, now the hardest one. 357. Yeah, it's dollars per gallon. It's not $3.57. It's $3.57 per gallon. I can't just say gas costs $3.57 without all of us assuming that we are talking about per gallon, right? Is it $3.57 for a gallon, for a tank, for a thimble of gas? What is it? We got to know how much gas we are talking about. It is not dollars. It is dollars per gallon. So we're going to put that here, dollars. What mathematical symbol means per? Division. Dollars per gallon. You buy it? Dollars per gallon. Okay, good things happen on the left-hand side. If we take a look at this multiplication, I've written it down below in number 4 without the numbers in front, just the units here. Dollars per gallon multiplied by the gallons, that's what we did first, and then we add the dollars, and we're hoping we get dollars when all is said and done, and we see that the gallon on the bottom and the gallon on the top cancel, right? And so that unit, just in that multiplication, becomes dollars. And dollars plus dollars indeed gives dollars. So everything works out. Unit on the left must equal the unit on the right. Okay, number 5. Changing gears and talking about ratios, and we're going to see that something called dimensional analysis techniques, the ones that we just used above here, will help us correctly set up proportions. So first, some definitions. Number 6, a ratio compares two numerical quantities through the operation of division. A ratio is often written as a quotient or fraction, such as A over B. A ratio can also be written A to B, and then that colon in there is also read the same as the first thing we said, A to B. A to B. 7, let's solve the following proportion. So that word means an equation stating that two ratios are equal. So proportion is just fraction equals fraction. The basic technique for solving proportions is to multiply both sides by both denominators. So let's take a look. The work is written out here, so we're just going to point as we zip through this. The original equation is here. X minus 1 over 7 equals 3 over 5. That is a proportion because it is fraction equals fraction. The technique we're going to use to get rid of all the fractions is to multiply both sides by both denominators. So on the left-hand side, we look at the denominators. We've got a 7 and we've got a 5. And on the left-hand side, we're going to multiply by 7 and 5. And on the right-hand side, we're going to multiply by 7 and 5. Yes? And it's not maybe clear why we want to do that, but at least it's one of the legal things to do, right? As long as you multiply both sides by the same number, you're okay. So we're multiplying both sides by 35, although I much prefer that you write it as 5 times 7 and not 35. On the left-hand side, something very nice happens. What cancels? It helps that stuff is on top. So what cancels on the left-hand side? 7. There's a 7 on top and a 7 on the bottom, and they go away. On the right-hand side, what cancels? 5. 5 on top, 5 on the bottom, goes away, and all of a sudden, no more denominators, right? And so now maybe it makes sense why multiplying both sides by both denominators is the right thing to do, because that's exactly what will get rid of both denominators, all at the same time. So the left-hand side, we're left with the 5, which is still there, times the x minus 1, which is what we had upstairs. And the right-hand side, we're left with a 7 now, and times the 3 that we had upstairs. And solving the rest of this is not very hard. I could have given this to you on the first day of the semester. You distribute, add the 5 to both sides, and then finally divide by 5 to get 26/5. One note, 26/5 is a perfectly acceptable answer. So if you have in your head that all of a sudden you're obligated to do long division on that, you aren't. Fractions are good. As long as you reduce them, full credit. Note, some students have learned how to solve proportions by this thing called cross multiply. Raise your hand if you've done cross multiply in your past. If you know how to do this, you are welcome to cross multiply to solve proportions in this class. I will never force you to do this idea of multiply both sides by both denominators. But it is risky to cross multiply unless you really know your stuff. I'm not going to talk about it anymore. I'm probably not going to use the phrase cross multiply anymore. I am just always going to multiply both sides by both denominators. But it will get you to exactly the same place if you do this cross multiply technique. Just make sure you do it carefully. Number 8, the ratio of male students to female students at GCC is 2 to 3. That's actually fairly accurate. If there are 2,000 students at GCC, which is also fairly accurate, set up and solve a proportion to find out how many are female. So 2,000 students, some male, some female, in that ratio, 2 to 3. And we're going to figure out how many are female. First, we're going to carefully define our variable. We'll try to use just one variable using a quantity word and a unit word. Now, it's already written out here, but in word problems, oftentimes figuring out what the variable is a stumbling block for many. But if you read carefully, the question is going to almost certainly tell you what I want the variable to represent. I'm asking you how many are female. That's what you should let x equal. Let x equal the number of students that are female. Number of female students. We've got both a quantity word, that's number, and female students is the unit. Good? Okay. Next thing here in the note, it says letting x equal females is not a good definition. If you are defining an x, it is a numerical thing. Females are not numerical things. There are lots of characteristics you can measure. Like even if you just say females, oh, you understand, I mean number of females. It's like, no, are you talking about the average height of the females? Talking about the weight of the females, the age of the females? Well, there's a lot of things that you can quantify about people. What you are trying to do is count them. And so you got to be explicit. Number of females, not just x equals females. Okay, number 9 says we're going to set up a blank proportion with 2 fractions being equal. Just fraction equals fraction. And writing that simple little thing there gives us the space to fill in what we're about to fill in here. Oftentimes people start writing like the first fraction and then they don't know what the x is, but they put an x someplace. Just give yourself the space, the structure, the skeleton of a proportion. Blank fraction equals blank fraction. Next thing we're going to do is fill in some units. We've got males and females in that ratio that was given, right? 2 to 3. So we're just going to put some unit words here. Now, it makes no difference the order in which we put these unit words. You could put males upstairs and females downstairs or the other way. Doesn't make any difference at all, but you got to make a choice. And I have made that choice right here. So as soon as I've made that choice, what do we have to write as the units on the other side? No numbers yet, units. No letters either, just units. Units on the left side have to equal the units on the right side. Females in the numerator, males in the denominator. They have to match. That's what we saw with the gallons and the dollars and everything. The units have to match. So as soon as you make that choice on the left-hand side to put females upstairs and males downstairs, you are forced to make the same choice on the other side. Nothing wrong with flipping it over. You could have chosen arbitrarily to flip it over. As long as you copy it on the right-hand side, you're good to go. I think putting those units in, while it might take you an extra 10 seconds to write the words down, will save you from the potential of having a fraction on the one side and then accidentally putting the flipped version of the fraction on the other side. Just write the words. Okay, next thing we're going to do is start grabbing some numbers. So up here it says males to females, 2 to 3. So that means on this first fraction, I'm either putting 2 over 3 or 3 over 2. One of them is dead wrong. You got to make sure you put the right one based on the words. This 2, does that represent females or males? Males, right? Because the males came first, and then the female number was second. And you just have to respect the order in which the words and numbers are given. It's consistent. So are we putting 2 over 3 or 3 over 2? 3 over 2. 3 over 2. Okay. Next thing we're going to do is get our variable in here. What did we let x represent up above? Number of females. Does that go up or down in this other fraction? Up. And it's really obvious that it goes up because we wrote the word females. But if we hadn't written the word females, it could have been really easy to put x downstairs, and you will get the wrong answer. This is the 10 seconds of writing the units to save yourself from getting the problem wrong. Okay, the trickiest part is this last blank here. There's one number we haven't used in the problem. It has to come into play. What is it? 2,000. What does 2,000 represent? Total number of students. All the students, males and females together, is 2,000. It is tempting to just throw the 2,000 there, but what word does that bottom number have to represent? Males. And 2,000 is not representing the males. It's all the students. Okay, some of you might already know what's supposed to go here. It's going to have x in it, and it's going to have 2,000 in it. And you might already just be able to see exactly what's going to go there. But if you can't, it's pretty straightforward if we use the technique from the other day where we said just make up a number for x and follow the bouncing ball. So suppose that we said, for example, that x is 100 female students. Just making up a number. What number would I put in the bottom there for the number of males? There are 2,000 students altogether. 1,900 is what's left over, right? If I make up 100 females, then there's 1,900 males. How did we get 1,900? What did we do? We did 2,000 minus 100, right? But it wasn't supposed to be 100. I just made that up. What was it supposed to be in general? X. So 2,000 minus x is what's going in that last blank. Like I said, some of you could probably have already intuited that this was supposed to be 2,000 minus x. I don't need you to make up a number if you're one of those lucky folks who can just see 2,000 minus x. But if you can't see it, it's no problem. You have a technique. Make up a number. As soon as you say 100 females, it's obvious. So obvious to you that it's 1,900 males that you might not even realize what you did to get 1,900. You just did it instantly. So just kind of unpack it a little bit. How did you get 1,900? Oh, I did 2,000 minus 100. Just change it, 2,000 minus x. Okay, that right there is a proportion. And if we get rid of the unit words, then we just have something that looks an awful lot like the proportion we solved on the previous page. You're going to solve that. You're going to finish this problem by solving it is the first thing in the activity today, all right? So we're going to put a pin in this. We got one more brand new thing that we're going to do together, but you'll finish this problem in a little bit. Okay, so last thing we're going to do here is something called a unit conversion, also known as dimensional analysis. It's on the next page. 14. In the US, a baby is born every 3.2 seconds. By the way, there are going to be a lot of problems in today's activity that start like this, and you might be wondering if they're, hey, is that really true? And the answer is no. I just made all of these things up. So, like, you can go find me a better statistic if you want, and I'll update it for next time. But this is just all fiction. These kinds of problems. Here's how we find out how many babies are born in the US each decade. That's what we're after. One baby every 3.2 seconds. We're going to translate to some massive number of babies in the US in a decade. Okay, we'll start with the given data, including units. One baby every 3.2 seconds. We buy that. One baby over 3.2 seconds. And we're just going to take that thing and we're going to be multiplying it over and over and over again by ratios that are equal to 1. We're going to multiply by things that are equal to 1. If you multiply a number by 1, what happens to the value? It stays the same. And that's kind of important. Like if you multiply a number by 2, it changes. But if I multiply a number by 1, it stays the same. So the only thing, like I can't take this 1 over 3.2, like that's just a decimal. You could get it on your calculator if you wanted to. Look, if I multiply that by 7, I have changed the value of that number, right? It's not equal to what it was a second ago. But if I multiply by 1, okay, well, it's kind of silly because I haven't done anything. And that's the idea. We're going to multiply by very particular forms of the number 1. But 1 is the only thing you can multiply by without changing. So here we go. I don't like the fact that this is seconds. I am trying to make my way to decades. Well, there are a lot of units of time between seconds and decades. What's the next one up from seconds to minutes? So here's what we're going to do. We're going to recognize that 60 seconds equals 1 minute. And so if I write the following, 1 minute divided by 60 seconds, I am writing a fraction where the top and bottom are exactly equal. Yes? And what is the value of a fraction where the top and bottom are equal? 1. 5 over 5, 18 over 18, top and bottom are the same, it's equal to 1. So I am perfectly within my rights. Don't write this down. But I could perfectly well put this here. And I say, hey, I have not done anything wrong because I have just multiplied by the number 1. Haven't changed anything. Now, putting the fraction like that, do I get to cancel the seconds? No, because they're both on the bottom. And I wanted it so that 1 would be on the top and 1 would be on the bottom so I could cancel. So what should I do with this fraction? Flip it over. You copy this. 60 seconds over 1 minute. And again, the value of that fraction is 1 because top and bottom are exactly equal to each other. And so I'm allowed to multiply that without changing anything. I've just multiplied by 1, and then we say, oh, wonderful. Seconds cancels, and the current units that are remaining are babies per minute. Okay, well, that's closer to decade than we were a moment ago. Let's try one more of these. We're going to multiply by. Okay, next unit of time from minutes, hours. So give yourself a blank fraction. You're going to do hours and minutes in some order. You've got minutes on the bottom. Where would you like to put minutes in this fraction we're building? Up on top because you want it to cancel. So let's put minute right there, hour right there. There's some fact you know about minutes and hours. 60 minutes in 1 hour. So let us write that fact like that. There are 60 minutes in 1 hour. 60 minutes equals 1 hour. Top and bottom are equal. So that's a fraction that is really just 1. And we built it in just the right way so that we can cancel minutes and minutes. And the units that remain at this moment, babies per hour. And that is getting closer to babies per decade. Okay? All right, so let's officially say that you are in group activity mode from this moment. You are going to keep multiplying by fraction after fraction until you eventually get to decades. Once you've got that, then it's just a matter of doing a calculation, probably on your calculator. How do you multiply fractions? Just across. So all you're doing on the calculator is typing in 1 times 60 times 60 times whatever else you end up putting there, divided by 3.2 times 1 times 1 times whatever else you put, right? So you're only doing the calculator at the very end, right? And lots of units and lots of other numbers in the meantime. Okay, so go ahead and finish this one, check in with each other, and then the group activity officially is on the next page.